Good afternoon, ladies and gentlemen, and welcome to this webinar on MasterFrame. I'm not going to go over a training session for MasterFrame. This is just a review of what MasterFrame is all about and what it can do. Certainly if you already use the software, you will still find advantage in watching what we're up to. This is a quick run through, particularly for people who have never used MasterFrame before, to let you see what it can do. So I'm just going to minimize my Explorer and throw up MasterFrame. So here we go. This is the Masterseries, and I'm just going to go into MasterFrame and open MasterFrame and have a wee look at typical frames. So if I just pull in this frame initially and then I go open, I can scroll down through typical types of frames that MasterFrame is used to design. So everything from your single span beam, your little domestic conversion A-frames, multiple beams if you so desire, trusses, portalized trusses, ground beams in domestic housing or industrial, typical plane frames. I'll just turn off the node numbers there so it looks nice clean. I think I've got another beam in here. A unusual portal industrial building with quite complex columns. A conveyor tower, so the conveyor belt's running up the middle here, and obviously I think running across here as well. Quite unusual. Industrial platforms and towers. More towers. A staircase. We can see a staircase here in 3 dimensions. And then we move into the larger, the 3-dimensional buildings. So we've got a portalized building with a first floor. Then we have a grandstand, quite an unusual little small awkward grandstand. Or something a bit more impressive would be the Newcastle stand. This is the corner of Newcastle United's football stadium. So as you can see, from the very straightforward to the very complex structures are all done using the Masterseries, and this is a lovely little shopping centre. I believe it's been manufactured in London somewhere. And then we can go into bridges and domes, and again some more industrial. This is a mining dome with a conveyor. I think the previous conveyor we saw coming into the top here to store all the spillage. And then we have scaffolding. So I'll not go any further. Quite a large range of shapes and sizes can be done with the one program MasterFrame. From your beams to your trusses to your little plane frames, to your space frame buildings, to your space frame industrial structures, to your grandstands and football stadia, all done using the one program called MasterFrame. And MasterFrame actually comes in different flavors, so if you're only looking to do small stuff, you only have to purchase a small version. If you want to do larger stuff, you can take a larger version or upgrade to the larger version. And we're so confident about the system that if you take a small version and upgrade later on, you only pay the difference in price. We don't put a penalty on you for being cautious at the start. So let's create a new frame. So I'll take a brand new frame and I'll just store it into a normal directory, and we'll call it demo. And create new. And the first thing we come across is our preprocessor. We can take a traditional shape and then kick it into shape to what we want. It's always best if you can to do that. We can also create a frame straight from a snap grid or a floor plan. I'm going to come in and take a multi-story and grillage. So this is our basic multi-story frame, and I'm going to go for 4 bays, and I'm going to go for 4 stories. and I'm going to go for a default span of 6 is fine, but what I'll do is I'll alter the first span to be 8, and then I'll alter the last span to be 7, but I'll do that in a different way to demonstrate. And we can put some basic loading onto it. So we can say the frames are spaced at 5 meters, and the dead load is 4. The live load is 5.5. So that's your basic load on, and we'll have fixed bases. And I'll just say proceed. So that's my basic frame. And if I turn on my lengths of members, I will see 8, 6, 6, 6. So I want to make these 7. So rather than doing it in here in the preprocessor, this time we'll look at changing the coordinates, and we'll just come in not to edit the list but to shift. So I can say shift all these, and just for the fun of it, that one as well, and we're going to shift them by 1 meter in the X. There's my X and my Y coordinates system, and I'll show it to you first and I'll say oops, I caught that one by mistake. So all I do is I go back and I just pick it to remove it out of the selection, and I say yes, that's what I want, proceed. So very simple to move a node about. If I reset that, I can take this node and I can shift it in the y-axis by 2 meters, and I'll say proceed. Now if I want to get this one onto a straight line, I don't need to get my calculator out and go 2 times 8 over 14. I can just instead go to my geometry and position a node on a straight line. So I can take this node and I can position it on a straight line from this node to this node, retaining the X coordinate. Retaining the X, that's what I want, and it's done. So that's one way. I can do the other side quicker just by taking everything out of this selection and just windowing all of it, because it will automatically choose the lowest and highest node numbers as my straight line, and I can say proceed. If I wanted to instead do an angle, I could reset and say I want to take this node and this node, and I want to start them at this node, and I want them to be a slope or an angle. So I can say -6 degrees, show to see if that's the correct, and it pulls it up to only being 6 degrees, and I say proceed. So it's very useful for setting out your structures. So now I want to create some more members, and members don't need nodes. If a member needs a node, it'll create a node. So I'll just come in and create a member. And the first way of doing it is between existing nodes and members. And I also get these additional snap points along each of the members. And if I look, it's a fifth, a quarter, a third, and midpoint, and likewise from the other node. So if I didn't want to use those, I can come along, I can say give me a member from there to there and a member back from there to there. If I wanted to, I could then say, well, this one's going to come along and it's going to come slightly down this member for whatever reason, I don't know, but it's just to demonstrate what we can do. And I could then take this from here and I can come along now either perpendicular to the member I'm attaching to, or perpendicular to the member I came from, which is quite useful. I can also create as a defined offset, so I can say at 1 meter I want a member. So at 1 meter along I can come along and snap, and again I can have my perpendiculars and my orthogonals. So I can introduce additional members very easily and quickly. We also have some very fancy these snaps. We can actually turn some of them on and off to reduce the clutter. We can do a parent intersection, as well. So we should be able to get an apparent intersection from this member. So if I go and say here, I'm getting the apparent intersection as a projection off that back member. So that gives me a straight line there. Again, very, very useful, these tools. And if we had grid lines in the three-dimensional, we could also snap onto grid lines, but that's not a standard MasterFrame facility. So that's some generating some members and moving nodes around. We've also seen how we can align members with each other. What I would like to do is to now move through, and I know this is a wee bit of a mishmash, and it doesn't really worry me because we probably won't be working on this frame for the whole webinar, is to define some section properties. So I can come along, and if you think about it, I've done my geometry, and I now want to come along and create the properties, so section sizes, and a quick run through of the vast array of section sizes that we can put onto members. Your initial default steel sections, you have your UBs, UCs, RSJs, your flats, your rounds, your European sections, your W American sections, your circular, your large circular, your jumbo circular. You have all these standard sections, your angles, your channels, your T's, your split T's, your parallel flange channels, and your old taper channels. So these are all here for you. You can actually go through and actually remove some of them from the list here. So if you're only going to work in the UK, you might want to remove the IPEs and the W sections. If you're working in Africa, you may want to also remove different ones. Even inside the groups, you can remove them. So you can say, I'm into UBs, but I want to remove some of the UBs. In this case, I'll put on a default 457, and then I'll just copy that onto these members. I'll then change, and I'll go for a built-up section, and I'm going to go for a built-up 500 deep section with 200 flanges top and bottom. Well, actually we'll make the bottom 250 wide, so it's slightly wider in the bottom, and I'll apply that to all these. And I don't need to go through doing all the different sections. So what I'll do now is we'll look at some concrete sections. So just for the fun of it, we'll take a concrete square section, or a rectangular, we'll make it square, 400 by 400, and we'll put that onto these columns. That's good fun, and maybe onto these. The next thing I want to look at is timber. If I wanted to do a timber section, say for example I wanted to work on this member as a timber section, I just come to the concrete and timber, because concrete and timber is really any prismatic section of these profiles in any material, steel, concrete, timber, or anything else, because you can just define your own E and G values to actually make it into something made out of plaster of Paris or glass or spaghetti, whatever you feel like creating your little model out of, in this case C20 timber, because the timber properties are all automatically built in. If we move back to looking at our standard sections, and I'm going to put a standard section up here, a steel section, I can now say, well, actually this steel section I want to be haunched. I'll go for a double haunch, and the length of the member is 6 meters 60. So I'm going to say double haunch of 0.75, and the other end haunch of 1.2. The initial depth will be 2, and the final one will be actually 3, just to see what it looks like. So that's what we're doing, and if I turn on 3D, you'll now see you've got a short, shallow haunch, a long, exceedingly deep haunch. So a ratio of 5 is a bit astronomical, a ratio of 2. Where we didn't define any sections, it's assuming the last section defined in the list, which was the column concrete column. Now, that's haunch sections. We've done our built-up sections. If we think about another section, and we'll make this one into a steel section, I'm going to make this into a UC, and I'm going to make it something quite simple, 203/46, and I'm just going to copy that to all of these. So that's our little small 203. But what I can also do in that, if I can say global, I can work on those four together, and I can say that I want to case it in concrete. And once I give this casing a dimension of say 25 by 25, it'll automatically case it out to be 50mm all round, so it's going to case it to 305 by 305 automatically. And that's done for all four of those sections. So we've got steel sections, we've got concrete, we've got timber, we've got cased sections, and we can even encase a beam. Obviously for columns, it's going to give you strength in compression. If you encase a beam, that just improves its lateral torsional buckling. So very simply, if I was to encase this one beam, just say a single member, I could say encase that in 25 by 25 and 30 Newton concrete, and you can see the casing is, and I can say, well actually let's make it 300 wide, just to be nice and square. Or maybe it was that one. It is. It's backwards. Breadth by depth. So 565, I'd make that 575. Something nice and easy to work with. So that's now encased in concrete. This column here, we can also go and we can make this into a cellular. So we now have a cellular form beam, and we can space our spacings at different distances if we want. And this beam here we can make into a compound section and either put a plate in the bottom. So I'm going to go for a bottom plate of 15. I'm going to make it 300 wide. So now we're beginning to see, if we go into 3D, we will see the plate 300 wide on the bottom, and that gives us a stronger section. And we could even put a secondary channel on top of it as well if we really wanted to. So a channel on top, plate in the bottom, a really silly section. So those are most of our section properties. What I now want to work on is the loading, and we also already saw some of the loading. We saw how we put a global blanket load on some of the structure, but let's take a detailed look at the loading. So coming into properties, loads, and we go to member loading. Loading's dead easy. As you can see, by default we have two loads on, and what I'll do is I'll turn on the load diagram so that we'll actually see our loads as we're working, and move back to the editing tab. And I can turn around and I can say in this one that actually the load is 5. Sorry, 14, and we can see instantaneously that growing. So take that back. 4.5 was the original, or was it 3.5? I think it was. Doesn't matter. It's something. But we can put additional loads on. We can add in a point load, for example, of 55 at 3 meters. There it goes. And we just need to scale the point load down a wee bit in our diagrams. If I go to this, I can actually pull that back down so it's not looking as astronomical, and back into my editor. We can put partial UDLs on. So if I go say 20 between 1 and 2, there we go. And if I turn off, just to make my life easier, the values, you'll see the shape of the load a lot easier. If I make that 3.5, we'll run it on through. We also then have the density, but we can handle densities globally anyway, so we don't need to worry about that. We have triangular loads, we have end moments, point moments, trapezoidal loads, And now we come to the really fancy ones, because what I can do is I can turn around and I can say that in fact I have an eccentricity horizontally of 200 millimeters, and then I have a 5 kilonewton UDL that's at that eccentricity, and then I add a second eccentricity. So only that one load, because that defines it, that applies it, and that sets it back to 0. So we can have eccentricities in the horizontal and vertical. So that's like a wall sitting on the outside leaf. We can then get into the really fancy things, and to do that I want to just turn off the load diagram and geometry, back to loading. We have these values here, and these are your powerful values for doing temperature rise, what coefficient you want to use, and what the rise in temperature or fall is. That's very straightforward. This one here is partial fixity, so I can say that this beam is not fully pinned or fully fixed, it is partially fixed, and I could say that I can have a 20% fixity in all directions, and since it's a plane frame that won't matter, so I'll get not full hugging but partial hugging. And we can apply that to beams and to bases, so we can put partial fixity on our bases, and we'll see that later on. We can take out a member, we can put a member in and tell it that it's deactivated. So I'm just going to remove that because I don't want to do that in this member, cut that out. If I was to go, say, for that member there, I can actually deactivate it so it doesn't actually do anything, and this one here, and I could deactivate it. I could take this one here and make this into tension only, because that kind of makes sense, and likewise tension only, and I'd say tension only. I can take this member and I can say no axial. So although it's there and it could take horizontal lateral loads, it won't take any load from this rafter, so it'll actually have no compression in it. And I could take this member here and I could tell it that it's compression only. These ones aren't really worth talking about in detail because they're quite technical. The ignore self-weight is used when you're doing sort of little cables and things like that to stop them from bending excessively in the graphics. But this allows you to create a realistic model of your frame. So that's applying loads, and yes, these are all considered to be loads because we can turn them on and off as we so desire. What we want to do now is look at loading cases and loading combinations. Each load normally has a load group D1 or L1 or even UT, and we can then turn on and off our loads in the different load groups to make use of patterned loading. So if I was to come along and out of this, and I was to go and open up another typical frame in here, that'll do. This is a concrete frame, that doesn't matter. But if we look at it in our editor and look at the diagram, we'll see our concrete beams, T-beams, L-beams. But what I'm interested in is the loading cases. And if we look, this is a rigid concrete frame. So what we're working with is, if I turn on my loads, I have got a loading in loading case 1 of all spans loaded. If I look at loading case 2, I've got patterned loading, maximum minimums, and then minimums, maximums, and then the serviceabilities. So I'm able to create all these load patterns, and that's because of the labels and the load groups. If you watch the tutorials on the training, then you will actually understand load groups in detail. It's not really what I want to look at today. I want to just give you a general overview of the power of the program. So let's look at our loading cases. We can see our 1.4s for dead and 1.6s for lives. But everybody I can hear in the background shouting, "Oi, what about Eurocodes?" No problem. You can obviously change these to your own, but you can just say, no, give me all the Eurocode equivalents and we can use the 1.25s and 1.5s for my loading combinations, and we'll see then that we get these patterns coming through. So we can handle both the British and the Euro codes and even the South African codes with their slightly modified factors on the British. I'm just going to go back to the British for the time being. One of the nice things about MasterFrame is that you can do a lot. You can do some very powerful things. I could take this frame and I could insert another frame. So for example, I could come along and I could say add myself a portal frame, and I could say let's locate the frame and we'll move it by, let's look at my lengths, or not my lengths, my x coordinates, 30 meters. So let's move it by, say, 45 meters. Shift by 45 meters, and it's over there out of the way. Now obviously this is a bit big, so I could say let's resize this frame to be about 0.3 by 0.3. So I'm going to resize the frame down. And I can then insert it and proceed. So I can create different frames, and in this case it's a very, very strange frame. So we can add frames like that. We can also come along and we can import not a frame that we're generating on the fly, but we can import a frame that's coming from a different file. So if you've analyzed the truss, you can then bring that in. So if I want to, add a frame that's an import, so I should have put those dimensions in on the previous page, you'll forgive me. So if I could come along and I could say I want to find some unusual frame, and just so I can see it on its own, I can come along and say no, that's interesting, what's that? So I could take this frame, or I could even take a copy of the existing frame, and I could add that again, and I could shift it in the Z by 5 meters. So what's going to happen is we're going to end up with two different versions of the same frame. If I go into 3D, you'll now see I've inserted a copy at a distance away. Okay, it is the same frame, so it's not that exciting. I could have done that itself just by doing a duplication. So let's do a couple of undos. And we're just back to our one frame. If I wanted to duplicate of that frame, there's no need to save it and insert it. I can just do that automatically. So I can do it what they call a duplicate. So coming in, duplicating the frame, I can take the whole frame and I can shift in the Z by that 5 meters and repeat it, in this case 4 times with tie members. Let's look at it in 3D, proceed, and we've now got our frame. If I just do an undo, I can also actually create more than one set. So I could say give me a second duplication after that of 2 repeats, and this time we're going to shift in the Z again, yes, but only by 2 meters, but we're also going to lift it up vertically by a meter. So it's a 2-to-1 lift, and I could then have a third one where I go back straight again. So 4 meters and 3 repeats. So what's it look like? It's going to look like that, and you can see coming along, going up in the vertical axis and then coming along again. So quite straightforward to do, and I can just say proceed. So that's duplicating, inserting frames. Foundation wise, and if I just undo that again, because I want to get just back for simplicity to the plane frame, it's just easier for you guys all to see. I put this in the front view. And what I'm actually going to do, I'm going to bring in a new file because I'm going to do some interesting things in a minute. I'm going to open an existing frame that I was working on this morning. If I go to recent, I will have my recent. There we are, a plane frame. It's a steel frame with a truss inserted into the middle, and the foundations by default, if I turn on my foundations, are fixed on the outsides and pinned on the insides. Pins, I have pinned my truss members, but I haven't pinned anywhere else. What I might want to do is to put an additional pin somewhere else. So what I'm going to do is I'm just going to come along to restraints, member releases, end release of a member, and I'm just going to pin that member there, and I'll pin this one here. I'm going to keep these all fixed for a reason. So that's those pinned, and I'm also going to, strangely enough, take these fixed bases. You remember the bases were fixed. I'm going to create a partial fixative. So although they're rigid, we go along to our restraints and we come along to the loads, member loads, and I'll take this column here, and at the bottom I'm going to ask to put in a part fixative of 20%. So this is going to be a 20% fixative, and I'll do the same there very quickly, but in this one I'll put it in as 50%. So we're now going to have a case where it's not fully fixed and it's not fully pinned, it's going to be partially fixed. The other things I want to look at is plastic hinges, because this is something we actually introduced in the 2011 version. It works beautifully. People have always been able to do a pseudo-plastic analysis if they could form their own hinges manually, but it was always a pain to do. So I'm going to create what they call potential plastic hinges. Put the plastic hinges in. So I can say I would have potentially form a hinge under the eaves at each of these columns, possibly on each of these beams, and there. So what will happen is at analysis time it will actually do an incrementing of the loading, and if hinges start to form, they will be formed, which is great, and it'll do it on a load case by load case basis. The previous method was a bit of a sledgehammer where you said yes, there's going to be a hinge there, and it just was not nice. So that's your plastic hinges. So let's go and analyze and then look at some output and some other things. So we've played around with geometry quite extensively. So analyze this frame as a plane frame, go to output, and let's look first of all at the tabular. So it doesn't matter which one of these, alright, you choose, you'll get your normal tabular output for each of the loading cases. Loading case 1 or loading case 2 for live load only. For member forces, we would get the ultimate loading cases with your axial, your shear, your bending, and your locations of maximum moment and deflection. So if I took this whole frame, I could say let's look at just that member and that member, and we'll see the axial at either end, and we'll see the shearing and the moment at either end of the member. So quite nearly zero up there because of the propping action. And we'll then see in span we've got a maximum sagging of 61 and a maximum deflection of 10 mil at 8.1 meters along the member. So quite detailed. If we now move along to the graphical, far more interesting, far more impressive. We can look at our bending moment diagram, and we'll shade this down, and we will see that we're not getting as much hugging as we would expect, and that's because hopefully plastic hinges have formed in some of these places and limited the hugging and sagging. So if I say draw the hinges, we'll see where we got all our hinges. So we nearly got all of them. We didn't get quite. We got where we could put the pins. We didn't get them. We didn't get them on the internal columns, but we did get them here. And we actually got them on this side, but not on this side. It wasn't hugging enough, so it's just not forming a hinge. And in this beam, it's not forming. It's only in this side. So that's quite useful. And we can even show the load factors for each of these hinges. So we can see that at 0.43, that's a bit low. I think the section would need to go up because it would be forming the hinges far too early. Likewise, 0.5 and 0.68 is probably a wee bit on the early side for forming your hinges. Interestingly, if you move to the second loading case, it hasn't done anything because it's a serviceability case. It doesn't attempt to form hinges. So that's your graphical output, your bending moments, your deflected shapes. Just turn all these hinges off. Deflected shapes with your original. And we can set our scales up to be a lot more sensible so we can see. And obviously you can naturally zoom in on a particular area, see what's happening, and ask for nodal displacements in the y-axis. And we can see a 55mm drop on the y-axis. What about horizontally? It's going to move 25mm horizontally in the ultimate case, and in the service 12mm movement. That's not too bad. I would be happy with that in a crinkly tin frame. We can also look at what they call in-span deflection, which isn't that much of a use for the rafters, but for the beams it's quite significant. And we can see our heavier loading on our longer span is giving us a higher deflection. That's looking at all the output. We can then print that output. So coming along, I would go and say print tabular. But before I do that, I might just say let's print the actual current graphics. So what I'd do is I'd say give me a 3D diagram of this beam, this bay only. Give me some section sizes, and I would say come along and print that. I will then come along and print this output, and I'm going to print it straight to the printer. And it's going to be PDF Creator and say print. So it's taking all the output. I'll close that, and just in case I'll just take a full frame. So back out the full frame. That's a bit much. I would probably go for half the frame, since it's asymmetrical-ish. That's still far too much. So I'll just take that with the graphic and go data, print, landscape, print, and then possibly turn off my section sizes, go to full frame, maybe just put on my X and Y coordinates, or just my X coordinates, give a bit of scale to it. Again, data, print, and I can also fine tune what I see so I can scale it up till it fits, and then say okay, let's go, and off it goes and prints that. Go into my output graphical and say let's take the bending moment diagram. Again, we won't need our X coordinates, we won't need 3D on, and we can print that off and say print. We can then say take axial and geometry, and this is quite interesting. I'm just going to close that for a second. If I just zoom in on this area here, if I go axial and say show values, that's going to be all the axial loads on those truss members, and I'm just going to reduce the font size down to something nice and small, say a 9 point, and that's enough because it'll be quite detailed on the actual printout. And if I go print and print, I will get that, and then obviously I can do any other ones I want. I can do my nodal locations, take off these values, and show all the hinge locations. Draw plastic hinges and print that if I want with their load factors, but there's no real need to. Let's look at what we've got from a frame analysis. Just closing my PDF session, the other page, so I just bring that in from my other screen. So there's your tabular results as you were expecting, the same as we saw on the screen. And then when we come on halfway down, there we go. First of our geometries, there's our other geometry, there's our bending moment diagram, and then there's our axial loads, and it always tells you what it is: axial force, compression positive, just so that you have no mistaking exactly what you're looking at. So that's the MasterFrame, the basic MasterFrame for frame analysis. But it's important to understand where that lies in the whole system. If I'm to come along and look a little model of the Masterseries makeup, here we are, MasterFrame, the core program sitting at the very heart of our system. It can interact with an advanced 3D modeler and wind analysis and finite elements. It can exchange drawings out to MasterCAD. It can bring drawings in from Revit. It can also start from Revit altogether. It can then take out into steel design, into composite, into concrete, into timber, and into connection design. We can also take our concrete through then to RC detailing and our connections out as DXF drafting. So it is sitting here as the heart of the whole system, this little program here. So let's have a look at where we can take the system, and it's all part of the upgrade path that's available for MasterFrame. So let's come back in and bring in a totally different frame of a totally different scale, just to show you where MasterFrame can go. So if I was to open a recent file, and it's going to be this bio here. Yes, it's a big file. It's a big frame. So what have we got? We've got a frame with some shear cores done in finite elements. We've got a slab, possibly a flat slab, with a transfer slab. If we put it into 3D, we will see that we have got a concrete substructure with ground beams and columns, a steelwork superstructure with bracing. We've even got some timber design. And all of this works together. So if I was to come along, I can say, having done my analysis, let's go in and look at some steel design. I'm not going to spend much time on this, but you can see, for example, a typical member there has been checked and been told that we're okay. We have all our different design checks. So we're looking at this one, it's a column simple construction. And if I turn off the 3D, we might actually find where it's at. It's away at the back there somewhere. It's actually one of these columns here. It's that one there. So it's showing the other similar columns at the same time. So the steel design is all there. We look at our bracing members, accurate with moment, on the raking columns. It's all designed and it's working. And in this case, we're actually working to the Eurocode design norm EN993, or otherwise known as EC3 to most people. So that's steel design. Very simple. Totally integrated. So start with MasterFrame today. You can move on to steel design tomorrow. Concrete design, same thing. We can take our little frame, a little bit of thought, and in it will come, hopefully not giving us too much trouble. And we just take one of these typical ground beams, we can see the ground beam with the reinforcement, and we would need to do some work on the reinforcement. We can look at our typical columns and see the design of those columns, and again this one is failing and needs possibly a bit more. It's just a curtailment problem. We probably need a bit more restraint distance. These distances are just too far apart. That can be worked on and sorted. This one, happy, it works. And that's your concrete design, from which you can then go through and do scheduling and things like that. I'm not going to do that. As I say, this is a frame analysis day. Design timber. You remember we little timber members at the start. So here we go. Pick one of these timber members. We can design it. We can see that it's pretty close, and that axial's a wee bit bad. It needs it to be stronger, or more of them, or less load. We can work on that again and design them. Timber is no real shakes, and also we can then go through and even do our connection design. And we'll do, what'll we do? We'll do an eaves type connection. I'm sure we'll find one somewhere to do. I'm quite certain that possibly that member. Oh, didn't like it. Maybe try one of the others. We can look at another frame if we have time on that, but the design is pretty straightforward in linking through into steel design, into connections. So that's the design part that I was talking about earlier in my little graphic of the frame. We also then have the modeling of area loading and finite elements, which are like your pre-processor and your advanced analysis. So what do we mean by area loading? What we mean is, rather than traditionally putting all the loads onto the beams, with the model manager, the 3D model manager add-on, we can create slabs and transfer the load. As you can see, it's doing it semi-automatically here, doing it all in the shortest distance each time, because he asked for the shortest distances, and doing it all pretty well. We can go in, if we just say level 2 and look at this, it's doing all the beams, and I just show my beams to help out, and we can see this one spanning back onto here and then across. It's the most logical. You could change that one around inside the editor and make it span more sensibly for you. So that's the area loading, and we can do patch loads and line loads all on the frame. If you come back out again, we also have the ability with the model manager to then put wind loading onto the frame. So if I go and say draw my wind loads, here's my frame with my wind pressures representing suctions and pressure. So the blue is pressure and the greens are suctions, so the high leading edge suctions you get here, and then tapering off, and then because of the back overhang of a canopy, you get additional pressure on that. So that's again a very, very, very powerful add-on program. Now I'm going to look at the questions, but I do know that one of the questions was, if I don't have wind analysis and I don't have the model manager, how do I put my loads, my wind loads onto my frame? Well, it's basically no different to any other component in the MasterFrame. You would just be coming along to a member, say that one. So you just go into loads, member loading. Sorry. And you would choose your member, and you would put on your UDL, but instead of being in the y-axis, you would tell it that is in the x-axis and give it the values accordingly. It's no different to that, and then you just work with your load combination. So there's a tool to allow you to set the angle of a member, as you saw me initially working through and setting the beta angle of one or two of the members. you can actually click on a member and set that up for you. I don't know if this is going to be an appropriate frame to find that out. No, it's far too square. I don't have a column at an angle or a beam at an angle to allow you to do that. If I look here, I might be able to find one very quickly. Is that skewed? If it's not skewed, I can soon make it skewed. Yes, it is skewed, and it's skewed in two directions. So if I look at this in 3D, this column here wouldn't really be sitting in the XY plane. So if I went to Properties, Beta, and I just probably, to make my life easier, just zoom in on this area. And if you look, this column here is sitting with a beta at the minute of 0. If you look at the tips down the bottom, use Control left and Alt left to pick the member to define the major and minor axis. So what I could do is, highlighting that member, I could go Control left, and it's now flicked around to being 92 degrees, which is probably not the way I wanted. So if I go Alt left, it's now sitting at 177 degrees. So it's orientated itself correctly. So that's one of the ways you can orientate your columns quite easily. How do you display a pinned end member? You display them by using this button here, which just shows me that my composite beams are pinned, and the circle means it's fully. I'll just turn off the betas, we don't need betas at the same time, and close that. So go back to pins only. So the true pin with a full pin in each end is represented by a circle, but where you're only pinning in the major and minor, but you're keeping the torsion available, then it's showing you the releases that you have as the 3 different components. And again, to do that is member end releases, and it's very straightforward. You just select what you want and you pick it, and pick it again to take off. So if you wanted to release the major and the minor but not the torsion, the reason for not releasing the torsion in this member is if this member had the torsion released at both ends and these 2 members are released in the major axis, this member here could just sit and spin like a barrel and will be unstable. So we normally don't release the torsion on beams unless we want to get rid of a torsional load. If we combine the wind loading without MasterKey Wind, this will affect the final design. Absolutely, you would be looking at doing the frame with all the different loading cases. And if I open another frame, possibly a portal style frame might be of interest if I have one. I'm not sure if this is an area loading frame or not. It is. Not that that actually really matters. Okay, you're going to get the loading cases, the loading generated for each member automatically, but you will have your load cases still to be created. And in this case, because it used the model manager, it created a lot automatically for you. But if you look, in this case, he's got dead plus live plus earthquake. He's got more earthquakes. What else has he got? Is dead plus live plus notional. So he's applied the notional and sway stability loads, which we didn't talk about, but is totally available. He's got his wind loads now. So he's got his dead and wind. So it's dead 0, dead 1, wind 1, and then a notional load as well, and an A load, which I think is a serviceability load. So the loading combinations you can set up are very straightforward and very, very flexible, so you can consider any combination of loading on the frame. Do you need the model manager to use the FE? No, the FE is an add-on, but it's an add-on on its own right and will work with the model manager. The only 2 programs that the model manager is required for is you would need the model manager if you wanted to do composite design inside MasterFrame, or if you wanted to apply the wind loading using the wind analysis program. Both those programs need the composite. But the steel design doesn't need the composite, the concrete doesn't need the composite. The model manager, the timber doesn't need the model manager. None of those need the model manager. Let me see, any more questions? I think I've covered everything. But what I will show you is if I come back in and load up the Masterseries. If I just quickly go to my login area, and those of you who are users will be able to log in, and go to training videos. This video will appear in the webinars in a day or two, or probably early next week usually. But also already in there, for those of you who are users of MasterFrame, is the MasterFrame training parts 1, 2 and 3, which go into detail and explain all the different components of MasterFrame. So it'll even give you a more detailed review. The concrete webinar, there's a steel design webinar, there's also using Revit with our Masterseries, there's the model manager training and the wind training webinars. So those are all available to you, and they're all most excellent webinars. And the last thing we're about to do is we've just had one of our engineers here rewrite all the tutorials, and we should be posting those up quite soon onto the website. So all the tutorials for all the different programs will be available very shortly in Eurocode and BS equivalents, and in steel and concrete equivalents, and some more ones that weren't there previously, such as truss design and things like that. So ladies and gentlemen, I bid you all either a good morning, good afternoon or good night. All the best now. Goodbye.